Hi viewers, in the previous video I have explained about the first two stages of the downstream processing. I think you will have a clear knowledge on solid liquid separation and release of intracellular products. Now I want to discuss about next three stages, that is concentration of product, purification, and finally the formulation of the product. Okay, so let's start our topic. Third step in the downstream processing is the concentration. The filtrate that is free from suspended particles contains 80 to 98% of the water. That is, the product is a very minor constituent. The water must be removed to achieve the product concentration. The commonly used methods for the concentration of products are evaporation, liquid extraction, precipitation, membrane filtration, and adsorption. First one, evaporation. Water in the broth can be removed by simple evaporation process. The instrument that is used for the evaporation process is called evaporator. The evaporators contain a heating device for steam and a unit for the separation of concentrated product and vapor, then a condenser for condensing vapor and control equipment. The capacity of the equipment is variable, that may range from small laboratory scale to industrial scale. Next, we can discuss the different types of evaporators. There are four types of evaporators used for the concentration of the product. That are plate evaporators, falling film evaporators, forced film evaporators, and centrifugal forced film evaporators. In the plate evaporators, the liquid to be concentrated flows over the plate. As the steam is applied, the liquid gets concentrated. In the case of falling film evaporators, the liquid flow down through a long tubes and it distributed as a thin film over the heating surface. Okay. Then in the case of forced film evaporators, the liquid films are created by mechanically and it is suitable for producing dry product concentrate. Fourth type of evaporator is the centrifugal forced film evaporators. A centrifugal force is used to pass on the liquid over the heated plate. It is suitable for concentrating the heat labile substances. It can evaporate very quickly. That is, a centrifugal force is used to pass the liquid over heated plate. Okay. Another method of concentration of product is the liquid extraction. That is the transferring of the product from one liquid phase to another liquid phase, and it is dependent upon the partition coefficient. Partition coefficient means the relative distribution of a substance between the two liquid phase. Okay, and this method is categorized as extraction of low molecular weight product and extraction of high molecular weight product. Third method is the membrane filtration method. It is used for the separation of biomolecules and particles and also for the concentration of fluids. It uses a semi-permeable membrane that retains the particles with a size greater than the pore size of the membrane, and the smaller particles can easily pass through this membrane. Membranes are made up of polymeric materials, so it is difficult to sterilize these materials. In recent years, microfilters and ultrafilters are available, and its sterilization and cleaning is easy. The filtration techniques are microfiltration, ultrafiltration, hyperfiltration. And the other types of membrane filtration techniques are membrane adsorbers, pervaporation, and perstraction. Membrane adsorbers means they are macro or microporous membranes, and these membranes contain ion exchange groups or affinity ligands, and these groups or ligands can interact or bind with protein. So the protein can be eluted by chromatographic techniques. Next one, pervaporation. It is the combination of evaporation and permeation. Okay, that is permeation plus evaporation gives pervaporation. It is useful for the extraction and purification of volatile products. And the last one, Perstraction. In this method, the membrane filtration technique coupled with solvent extraction. Precipitation is the another method of concentrating the molecules. It is the simple or most common method used for concentrating macromolecules like proteins and polysaccharides, and it is also used for the removal of unwanted byproducts like nucleic acid and pigments. The change in temperature and pH are used in the precipitation. In addition to this method, there are some protein specific precipitation, which include precipitation with a neutral salt or with organic solvent, non-ionic polymers, precipitation with ionic polymers, affinity precipitation, and precipitation by ligands. First one, precipitation with the neutral salt. The most common used salt is the ammonium sulfate. Ammonium sulfate increases the hydrophobic interaction between the protein molecule that causes the precipitation. And this type of precipitation depends upon certain factors like protein concentration, pH, and temperature. Next one, precipitation with organic solvent. Example, ethanol, acetone, and propanol. They reduces the dielectric constant of the medium and enhances the electrostatic interaction between the protein molecule that causes the precipitation. Another method of precipitation is with non-ionic polymers. The best example is polyethylene glycol. Polyethylene glycol can reduce the water availability and causes the protein precipitation. It doesn't cause any toxic effect or denature the protein. Then ionic polymers can also be used for the protein precipitation. Example, polyacrylic acid and polyethylene imine. It can form complex with oppositely charged protein. Okay. The charged polymer, that is the ionic polymer, can make complex with oppositely charged protein molecule. Okay. So that causes the charge neutralization and precipitation. The increase in temperature and change in pH also causes protein precipitation. Also, affinity interaction used for the protein precipitation. Then ligand with a specific binding site for proteins can also be used for the precipitation. So this is about the precipitation reaction or the concentration of product by using precipitation. Last method, adsorption. The product of fermentation can be concentrated by using adsorbent particle. Adsorption is by making a bed of adsorbent column and passing the culture broth through it. So the product make interaction with adsorbent and the product can be eluted. In the early days, the activated charcoal was used as the adsorbent material. In the recent years, cellulose based adsorbent materials are used. And for the concentration of low molecular weight compounds like vitamin, antibiotic, etc., polystyrene, methyl acrylate, acrylate based matrices are used. So the adsorption can be used as a method of concentration. Okay. Next, we can discuss the fourth stage of downstream processing. That is the purification. Purification is by chromatography. Chromatography can be defined as the analytical technique deals with the separation of closely related compounds from a mixture. And this technique consists of a stationary phase and a mobile phase. Stationary phase is the porous solid matrix packed in a column, one to which the mixture of compounds to be separated is loaded. The compounds are eluted by mobile phase. There are different types of chromatographic techniques are used for the separation of compounds, which include gel filtration chromatography, then ion exchange chromatography, affinity chromatography, and hydrophobic interaction chromatography. Okay. First method of chromatography is the gel filtration chromatography. It is also called size exclusion chromatography. And this chromatography technique is based on the size, shape, and molecular weight of the molecule. Okay. This method uses sponge-like gel beads with pores. That is, a gel beads with pores. And these beads serve as molecular sieve for the separation of smaller and bigger molecules. The solution that contains the smaller particles and bigger particles applied to the column and then eluted. So, the smaller molecules can easily enter the gel beads through the pores and get trapped in the gel beads. But in the case of larger molecules, they cannot pass through these pores and therefore come out first with the mobile liquid. So it is used for the separation of smaller and bigger molecules. The bigger molecules can be easily collected. Okay. Second type of chromatography is the ion exchange chromatography. It is a chromatography based on surface charge. There are two types of ion exchangers: anionic exchangers and cationic exchangers. Anionic exchangers are positively charged and the cationic exchangers are negatively charged. Ion exchange chromatography is depend upon the pH of the solution. The pH of the medium is very important since the net charge varies with pH. We can say the pH determines the charge on both the target molecule and the ion exchanger. So the ionic bond molecules can be eluted from the matrix by changing the pH of the solution or by increasing the concentration of the salt solution. Okay. Third type of chromatography, affinity chromatography. It is used for the purification of protein from a complex mixture. It is based on the interaction of protein with a ligand. The ligand can be a specific antibody, substrate analog, or an inhibitor. Okay. Example, the ligand antibody used for the separation of protein antigen. Another example, the ligand cofactor used for the separation of the protein enzyme. The ligand receptor used for the separation of the protein hormone. Okay. So these are the some of the examples of ligand used for the separation of protein. The protein bound to the ligand can be eluted by reducing their interaction. The interaction between the protein and ligand can be reduced by changing the pH of the buffer or by altering the ionic strength or by using another free ligand molecule. Okay. These three methods used to reduce the interaction between the protein and ligand. That is the changing of the pH, changing the ionic strength, or use of free ligand molecule, another free ligand molecule. Okay. Then the fourth method of chromatography, that is hydrophobic interaction chromatography or HIC. It is based on the weak hydrophobic interaction between hydrophobic ligand and hydrophobic amino acids of the protein. Hence the name hydrophobic interaction chromatography. The proteins eluted by lowering the salt concentration or the polarity of the medium. The last and final stage in the downstream processing is the formulation. Formulation is the maintenance of activity of a product during the storage and distribution. For the low molecular weight product, the formulation is by concentrating them with removal of water. For the smaller molecules, Formulation can be done by crystallization by adding salt. Proteins are highly susceptible for the loss of activity. Protein shelf life can be increased by adding stabilizers. Stabilizers include sugars, salt, and polymers. Sucrose and lactose are the sugars used to increase the shelf life. Salts include sodium chloride and ammonium sulfate, and polymers include polyethylene glycol. Proteins may be formulated in the form of solution, suspension, or dry powders. Drying is an important component of the product formulation. It involves the transfer of heat to a wet product for the removal of water. Some of the biotechnological products or the industrial products of fermentation are sensitive to heat. So, it requires gently drying methods. Drying devices are classified as contact, convection, and radiation dryers. Then another method of formulation is the spray drying. It is used for the drying of large volume of liquid. A small droplets of liquid containing the product are passed through a nozzle, directing it over a stream of hot gas. So the water evaporates and the solid particles are left behind. Okay. Then the third method, freeze drying or lyophilization. It is the most preferred method for drying and it is suitable for heat labile products. Lyophilization doesn't cause any loss of biological activity of product. It is based on the principle of sublimation of liquid from a frozen state.